Notes on the history of fork and join. Introduction to fork and join. Fork and join are fundamental constructions in concurrent programming that enable parallel task execution. They facilitate dividing a program into multiple tasks that can run simultaneously and then synchronize their completion. Understanding their history helps appreciate their role in modern computing systems. Origins of parallel computing. Early computing systems relied on sequential processing before the advent of parallelization. The need for faster computation led to research into concurrent execution methods during the 1960s. These efforts laid the groundwork for constructs like fork and join to manage parallel tasks efficiently. Early concurrency models. The concept of process creation and synchronization appeared in operating systems during the 1970s. Unix introduced the fork system called to create new processes influences later. Early concurrency model. The concept of process creation and synchronization appeared in operating systems during the 1970s. Unix introduced the fork system called to create new processes, influencing later concurrency patterns. These models provide the foundation for higher level abstractions such as thread-based parallelization. The emergence of fork in programming languages, the fork system call became a standard in Unix-like systems for process creation. It allowed programs to split into multiple processes that could run independently. This model influenced the development of parallel programming constructs across different languages. Join operations in parallel computing. The concept of join emerged as a way to synchronize parallel tasks, ensuring they complete before proceedings. Join operations allow combining results from independent tasks in a controlled manner. They become essential in managing dependence and data consistency in concurrent programs. As we see in a picture, join operations in parallel computing. The concept of join emerged as a way to synchronize parallel tasks, ensuring the ensuring they complete before proceeding. Join operations allow combining results from independent tasks in a controlled manner. They become essential in managing dependency and data consistency in concurrent programs. Theoretical foundation of fork and join. The formal study of parallel algorithms incorporated fork and join are fundamental primitives. These constructs are modeled in various process algebra frameworks to analyze concurrent behaviors. Their formalization helped optimize and verify parallel program correctness. Fork join parallelism in model programming. Languages like Java introduced the fork join framework in Java 7 to simplify parallel task execution. The framework efficiently manages thread pools and task splitting with recursive fork join patterns. This model becomes central to developing scalable parallel applications. This model becomes central to developing scalable parallel applications. The role of fork and join in multi-threading. Fork and join enable dividing a task into smaller subtasks and later combining the results. It means like if you have a large task, the task would be divided into smaller subtasks by the help of fork and join in multi-threading, and later combining the results, which means by decreasing the length of the task and by getting all the results of the small tasks, which leads to the result of the large task. They are widely used in multi-threaded programming to improve performance and resource utilization. They are mainly used in multi-threaded programming, means in which the program task is very large. Therefore, they use fork and join to reduce the task into small subtask, and the programming improve performance and resource utilization. So, proper synchronization through join ensures data integrity and program correctness. The insurance of the synchronicity ensures data integrity and program correctness. Implementations in contemporary frameworks. Modern frameworks like fork join pool in Java and task parallel library in NET implement these concepts. They provide high level APIs to manage parallel execution seamlessly. They need very high level APIs to execute the task. These implementations abstract away low level thread management complexities. Challenges and limitations. Overusing fork and join can lead to overhead and reduced performance if not managed carefully. And as we know, if a process or method has advantages, it also consists of disadvantages. The disadvantage of using uh, fork and join method can lead to overhead and reduced performance if not managed carefully. Synchronization and data sharing require meticulous design to avoid these rare conditions. Understanding their history aids developers in applying these constructs effectively. Historical impact on computing architecture. The development of fork engine influenced the design of multi-core processors and parallel architectures. They contributed to the shift towards hardware and software co-design for parallelization. This synergy has driven advancements in high performance computing. Case studies in parallel algorithms. Many classic algorithms such as merge sort and matrix multiplication utilize fork join patterns. These case studies demonstrate the practical effectiveness of the constructs. They also highlight best practices for applying fork and join in real world scenarios. Future directions in fork and join. Emerging areas explore dynamic scheduling and adaptive fork join strategies. Integration with distributed systems and cloud computing presents new challenges. Ongoing research aims to improve efficiency, scalability, and ease of use. Then there was the summary of key points. Fork and join are integral constructs in the evolution of parallel programming. Okay, we understood the point like fork and join are integral constructs in the evolution of parallel programming. Their history reflects a continuous effort to harmless concurrency effectively, and the result of the reflects on the upcoming programming codes and tasks. Mastery of these concepts is essential for model high performance application development, and to master these concepts is essential for the modern performance application development. Then the conclusion. The development of fork and join has significantly impacted computing from OS processes to high level frameworks. The revolution exemplifies the progression toward more abstract and manageable parallelization. Continued innovation in this area promises to shape the future of computing technology.